Hi, in this series, we'll be continuing the 2020 H2 Mathematics Paper 1. We left off at question 3, and for question 4, it is testing us on complex numbers. So we are given 3 complex numbers and we're supposed to find Z1 over Z2, Z3. So the way to do this, well, it is to convert all the forms to the exponential form. As in exponential form, you can really manipulate the terms easily because exponential is easy to play with. So you have Z1, which is this, and Z2, which is square root 2 EI minus pi over 4, and Z3 is this 2 EI pi over 6. Why do I say you can manipulate easy? Because you don't need to do any cross multiplication with two terms or anything and simplify. Instead, everything is in power form already. So when you write it as a division, this is easy. You can just combine the coefficients can like cancel out in a sense. You get out the constants, and for the E, you just need to bring up the power and then you just do subtraction or addition to the top and bottom power. So it's pi over 3 minus pi over 4, so it's plus pi over 4, then minus pi over 6. And you should get this answer. Then from here, now we can, because we want it in R cosine theta plus I sine theta, we know this can be written as cosine 5 pi over 12 plus I sine 5 pi over 12. So that's easier to do compared to doing Z1, Z2 in such a complicated manner. Now we know that there's a Z4, and this part is purely imaginary, and the modulus is 1. So Z1 times Z4 over Z2 times Z3 is just going to be this number, because you got this part already, you know, times Z4, which is just going to be REI theta. So in the end, this will be R square root 2 EI 5 pi over 12 plus theta. Since we know the modulus is 1, means this part has to be 1, which means R is square root 2. So we got that out of the way, we can now find the possible values for theta. And we know theta must lie within minus pi and pi. So since this is purely imaginary, it means that this upper value, this angle must either be 5 pi over 12 plus theta equal to pi over 2, or it must be minus pi over 2. So when it is pi over 2, then theta is just pi over 12. And if it's minus pi over 2, then theta is minus 11 pi over 12. So I hope that's clear. Hence, Z4 will either be square root 2 cosine pi over 12 plus I sine pi over 12, or it will be Z square root 2 cosine minus pi over 12 plus I sine negative 11 pi over 12. Next, question 5, it tests us again on vectors. Given that AB cross multiply equals to BA cross multiply, find the relationship. So we know that B times A cross multiply, we need to put a minus to flip the two. So it's actually just minus A times B. So A times B equals to minus A times B. This can only mean one thing. It can only mean A cross B is 0, because the only number that x equals to minus x is just 2x equals to 0. So x equals to 0. So A cross B is 0. It means either 3 things. A is 0, B is 0, or A is parallel to B. But since A, B are non-zero vectors, it just means A must be parallel to B. So A is just some scalar multiple of B. So you can just write this relation, or you can just state it in words. For part B now, we are given PQ is fixed and R varies. So PQ is like some numbers here and R varies. Like R can be like anywhere. Then, given that Q is non-zero and R minus P times Q is 0, describe geometrically the set of all possible points. Well, if r minus p cross z is 0, we can refer back to over here. But we also have the case where r minus q equals to 0, which means r equals to q. But we'll take care of this later on, and you'll see why. Because r minus p is parallel to q, means r minus p equals to some lambda times q. This lambda can also be 0, so it's actually within the same, it's already encompassed in the case where r equals to p. So we don't need to care about the r equals to p case, because it's already taken care when you write this line. So by writing that line, we know that it's some scalar multiple, so we just need to bring the p over. So actually r equals to p plus lq. This means that r represents the position vector of the point on the line parallel to q and passes through p, because this is the equation of a line as lambda varies. So r is just that point, the position vector of any point on the line. So I hope that's interesting to solve, and you actually gain some insight from doing it, and you realize how you can also write an equation of a line using this method. Now we are just given the vectors r, p, and q respectively, and we're supposed to find the relationship with x, y, and z. So, but now instead of cross, it's a dot, multiply. In this case, because you already got like somewhat the values, you just need to dot multiply normally, and you will see that this 3x minus 5y plus 2z plus 5 equals to 0. This means that 3x minus 5y plus 2z equals to minus 5. And that is really basically the relationship between x, y, and z. So we want to find all the points. Well, this is just an equation of a plane. So you can just put the tuple and then just put this condition, which is fine. Or you can just say it's a set of points on the plane which has a normal vector 3 minus 5, 2. So it depends on whether you want to write in set notation form or describe it out. Lastly, for question 6, we are given the complex number which is z, which satisfies this quadratic equation, and we already know one of the roots is k plus ki. So the natural thing to do, because we see that these are not real coefficients, so we cannot do our standard way of subbing in the knowing that k minus ki is a root. So this doesn't work. So we need to just sub in k plus ki and see what we get. And we are able to reduce it all the way to get that. And then it works out, because when we reduce it all the way, we know that this I portion has to be 0, and we're able to solve for k. And since k is not 0, we know that k must be 2 in this case. With that, we know this part is also 0, 8k plus t minus 2k squared, and this allows us to sub the k as 2 and find t, which is minus 8. Then we are able to sub back into this equation, minus t equals to minus 8, and then just use the quadratic formula to solve for what is z. And z, you see, that will become 2 plus 2i, or minus 2 over 5 plus 6 over 5i. Since we already know the k plus ki is one solution, the other root has to be this one, the minus 2 over 5 plus 6 over 5i. So while this seems tedious, and it is, you don't have much information to play with, so the best you can do is just sub in and see where it goes. And then, because the questions will lead you on, you are able to solve it naturally in that order. So that's all for this video. I hope you have enjoyed it, and if you have any questions or any explanations you want me to go through again, you leave it in the comments and I'll do it. Thanks. Bye.